The last part of section 2.2 is looking at common factors. And so if you have something in common, it means that you both have it. So a common factor is going to be a factor between that both of the numbers you're looking at has. So if you were looking for the common factors of 16 and 24, we can see 1 is a common factor. They both have a 2. They both have a 4. And they both have, oh no, yep, and they both have an 8. So the common factors then are 1, 2, 4, and 8. The greatest common factor is something we're often concerned about in math. It will really help you when you're reducing fractions later on. So the greatest common factor is going to be the greatest or the highest of those common factors. So here then, the greatest common factor is going to be 8. Now, if you want to find the GCF, so if you were, which is the greatest common factor, you could do this. So if you were asked to find the greatest common factor of 16 and 24, you could list out the factors like we have here and figure out which is the highest one in common. But there's an easier way to do it. So the shortcut way is to first write out the prime factorization for each of the numbers, and then you're going to find out what prime factors are in common. So which prime factors do they share? Once you've figured out which prime factors they share, you just have to multiply those numbers together, and that will give you the greatest common factor. Right? If there are no common prime factors, then the greatest common factor is just 1. All right, let's try some examples. So here we're asked to find the greatest common factor of 30 and 36. So let's figure out the prime factorizations. So let's do the tree here. So 30 is 5 times 6. 5 is already prime. 6 is 2 times 3. So if I was going to write this as prime factorization, I would say 30 equals 5 times 2 times 3. Okay, let's try 36. So 36 is 6 times 6. And 6 we can break down into 2 times 3. Okay, now we have our prime factorization trees. We're going to circle everything that's in common to both trees. We're going to circle our pairs. So I have this 2 in common, and I have a 3 in common. Maybe I'll do that a different color. So, and I have this 3 in common here. So the GCF, or greatest common factor, then is going to be the 2 times the 3. Okay, so, and that gives us 6. So the greatest common factor here is 6. All right, let's do another. So this time we want the GCF of 3 numbers. Let's try the chart method, or the division method. So I've got a 16, and I know 16 is divisible by 2. That gives me 8. If I divide that by 2, I get 4. If I divide that by 2, I get 2. 2 is prime, so I am there. Okay, and let's do the same thing now for 24. Okay, once again, I can do a 2 to get 12. I can do another 2 to get 6. And another 2 to get 3. 3 is prime, so we've got our list of prime factors on the left. All right, let's do 32. I can do a 2 for 16. Another 2 would give me 8. And another 2 would give me 4. And one more 2 would give me 2. So now I've got all of my prime factors for all 3 of these numbers. So what I'm going to do is circle numbers that are circle prime factors that are in common to all 3 of these. So we've got 1, 2 here. We have another 2 in common, and another 2. And that's it. Those are all 3 that are in common to all 3 of those. So then our GCF is going to be the product of those common prime factors. So 2 times 2 times 2, which gives me 8. All right, we've got some bigger numbers here, but the same principle applies. So go ahead, pause the video, and try those next two on your own. Okay, so hopefully you had a chance to do these. Let's try them together. So we've got 147. Maybe I'll write it a little bit further. 147. Okay. So we're looking for something that divides into 147. And I can tell from my divisibility rules that it's going to evenly divide into 3. So 147 divided by 3, what does that give me? So I get 49. And 49 is 7 times 7. Okay, and those are primes, so I'm done that tree. Let's do 210. So that's 21 times 10. 21 is 7 times 3. And 10 is 2 times 5. So I'm left with only prime numbers. Let's see what we have in common. Well, I see a 3 that's in common to both, and a 7 that's in common to both, and that's it. So our greatest common factor then is going to be 3 times 7, which is 21. Okay, let's try the next one. So I'm going to do the division method. So we're looking for 15. That's divisible by 5 to give me 3, and 3 is prime. So I'm done that one. Let's do the next. Okay, 30, I could divide into, that's divisible by 2 to get 15. 15 is divisible by 5 to get 3, and I've done that one. And last one, I've got 45. So 45 I can divide into 5 to get 9. 9 is divisible by 3. 9 divided by 3 gives us 3, and there, I'm done that one. Let's see what we have in common. Well, we have a 5 that's in common to all 3 of these. And we have a 3. And those are the only 2 things we have. So our GCF then is going to be 5 times 3, which is 15. So that's our start of looking for greatest common factors, which once again will be super useful when we get into reducing fractions down to their lowest terms.